As promised, this is the Patreon release for the JVC RX9V raw footage, so you can see everything, all the stuff I went through and chopped out in the final video because it was kind of excessive. This is the JVC RX9V stereo receiver that was shipped in by a viewer to have a look at. And I don't think I've ever seen so much packing tape used. It took me, I'm kidding you not, about 15 minutes to unpack this thing. So let's figure out what's wrong with it. Now, normally people include a description of what the problem is, but this one came with no such info. Now, I'm sure somewhere back in the correspondence of emails back and forth on this before it was sent in that the problem was described, but again, I don't have the email sitting in front of me. I receive upwards of between 400 and 500 emails every single day. So to go and actually find the email for this is going to take a while. So let's just power this unit up and see whether it does anything. So it sounds like it's not doing anything. Totally dead. Obviously this thing's got a short somewhere in it because it just popped the only fuse that I've got for my Variac and my bench power supply. So now I gotta make a trip into town and pick up some fuses before I can do anything on this. Damn. Okay, I got a new fuse in. I'm gonna run this through the big dim bulb tester now, so I've got it plugged into the power supply, the current limiter, so that I won't fry another fuse. Would have been nice to have known that it had a short in it. I'm sure somewhere in the correspondence that was there, but a note from the guy shipping it in saying, hey, it pops fuses, or it's dead, or it blows fuses. That would have been nice to know before plugging it in. Okay, so I just turned on the power and we saw the dim bulb blink momentarily there. And that's all. In fact, that's all it does. I turn off the power to the bench, turn it back on. You'll hear a relay click momentarily. And we're going to see the big dim bulb there just kind of glow momentarily and go out. Oh, that time it stayed on. This time the receiver stays on. What the heck? It's all lighting up. The fact that my 100-watt bulb is just barely glowing means this thing's not drawing a huge amount of power. I don't have the speakers turned on or anything on here at this point. Let's just see whether it does anything when I turn on the speakers. I'm going to obviously listen for a pop or click or anything. Nothing. And the power button turns it off. Well, definitely there was a short there. That short is now gone. Let's just see whether this will actually receive anything. Volume. Oh, it's in CD mode. So let's just put it into radio mode and see whether we get any sound. Tuner. Hook up an antenna. Okay, I got an antenna hooked up to it. See if I pick anything up. Okay, it's a signal there. Where's the FM muting? Ah, I have sound. Okay, put a little wire on there for the antenna because my big antenna on the roof won't really pull in my little test transmitter here because it's so weak. It doesn't make it far enough to the rooftop antenna. It only goes about, I don't know, 30 feet or so. Well, this thing appears to be well, this thing's working at this point, which is weird. I'm going to pull the unit apart because obviously there's a problem with it, as it did blow the fuse initially, and I had to go get a new fuse for my isolation transformer. So something inside here is obviously shorted, and the first time I turned it on the current limiter, of course, the light lit up really quite bright for a second and then it shut down. And when I power cycled it, it then came on. So something in here has an intermittent short. So I have to open it up and investigate. So I got it apart, went to turn it on, and it did the same thing. Let's see whether when I hit the power again, whether the light will blink. See, now it's got the short. The short is back. Now do it the third time, and it comes on. Weird. Something shorting on this unit. See, even if there's a complete dead short, that light will just go bright now. But it's like it's trying to start. Hear the relay click, and then it cuts out immediately. But it's not enough of a short to blow any fuses internal because both channels are working. But something is causing so much current to draw that it's locking it up, because once it happens, the power button has no effect. Unlike many of the new receivers and amplifiers, this one here has hatches that you can remove on the bottom to inspect things, looking for solder splashes in any places where there may be shorts. There, did it again. It's on now, but it clicked and then went right off. And I can't do anything unless I turn off the power. Try to do this in one shot so you guys can see. So the light blinked and it went out. Turn it off, turn it back on, and now it's going to work. Now something interesting. Note this. Oh yeah, the panel lights are on. I just didn't see it from the angle I was sitting. I was looking at it too low. Looked like the panel lights weren't on initially, but they are. Just from where I was sitting, they didn't appear to be on. So if it sits for a couple minutes and turns on, it seems to do it. And then once it's running, it runs weird. I mean, I'm looking at the board here. I don't see any solder splashes or anything. It's like something that needs to charge up, almost like the main filter capacitors are drawing a lot of current as they go to charge the first time, and once they've been charged up, they're okay. But initially getting the charge in them, if I let it sit for a few minutes to completely discharge, and then I try to start it, it's going to trip the, it's going to draw too much current, it's going to trip the overcurrent. But it's not blowing any fuses on here, which is the strange part. So we'll try it again now. It's been sitting for a couple minutes and just see if it'll do it or whether it'll turn on. That time it's going to work. See, normally you get the bright light like that when the main filters are completely discharged. It's going to draw a lot of current to charge these up, and then once they're charged, the current will drop. So it's normal when you first turn the power on, you get the inrush, the light's going to go bright because it's going to draw full current there for a few seconds as the capacitors charge up. But when it acts up, it doesn't do that. It just goes click, like a double click, and latches up. We'll let it sit for 5 minutes. There, see? It's done it. And I have no control until I turn off the power and turn it back on. Now, it may have just been a coincidence that it blew my fuse, because the input fuse on this is rated at 6.3 amps and my fuse on my bench is 3.5 amps on my isolated power supply. So that may be why it popped the fuse, and that it's not drawing too much current. It's a shutdown problem in the unit itself. So let's just try it without plugging it into my isolated bench. I'll plug it directly in. I'll still go through the current limiter bulb and see what happens. And then if it starts up okay, then we'll try it without the current limiter. I'm trying to isolate the fault. It might actually be something in the microcontroller part that's locking up, because when it does do it, you can't turn it on and off with the power switch like this. It locks out. It goes on off, and then the power switch locks. So it might be something in the power supply for the CPU that's one of the low voltage supplies in the standby. It might be that's causing it. It might be a faltering voltage in the standby. Now when you first turn it on, the standby voltage isn't quite high enough. So let's plug it right in. Still going through the bulb, plug it directly into power and get my isolation transformer out of the circuit, because that fuse blowing in there might have just been a coincidence, just because this unit has a high inrush current when it first starts. Okay, the unit's plugged directly in now. Let's hit the power. Same thing. Same thing happens, but if I unplug it and plug it back in, it'll work. Now, if I'm going to dive right into this thing not knowing anything, I'm first of all thinking standby power, which is this one here, because the microcontroller is kept running from this supply. This is the power supply that energizes the relay to turn on the main transformer. And what's happening when you first hit the power button, when it's dead cold, is the relay is energizing momentarily, and then it's de-energizing, and the unit is locking up. And when you remove the power and put the power back on, it's working. So it might be one of the voltages is a little bit low coming off of the standby. And the standby, of course, is regulated by these two little filters here. So let's pull the standby board out first and just take a look at these standby caps. And of course this will reveal the main power supply down here as well. But I don't think there's going to be a problem with that. I think the problem is going to be somewhere here in one of these standby supplies is causing a problem. Let's observe what happens when I disconnect the power that goes to the main board. Will the standby supply still do the one cycle? Okay, the relay is now toggling on and off like it should. See that? You can hear it. Let's reconnect the main transformer and watch the sequence as it tries to power up the main part of the amp. Okay, try it again. Now it's shut down. Interesting. So it doesn't do it when just the standby supply is running by itself, but it does when the main power supply tries to come online. Interesting. So that plug that was plugged in, that was actually the secondaries. The primary is fed with the brown and orange wire. So with the secondaries unplugged, the primary was still getting power. So the primary is not causing, the transformer is not causing the problem. It's something that's drawing excessive current in the secondary that feeds down to this power supply here. So let's pull out this board and take a look underneath this board here at the regulators and the caps on the main board, the main filter board. Well, right up front I see there's some connections in here that are not too good. This is unplugged now, so I don't have to worry, but look at this one here. This is on a diode too. That looks like that's cracked all the way around. Same on this side here. There's a few connections on this board that leave something to be desired. So before I start changing any parts, I'm just going to go through and I'm going to redo all the connections on here that look a little bit flaky. There's a couple. Because there's regulators on this board as well. And I would imagine that the standby voltage or the low voltage is probably regulated on here. And if there was a fluctuation of the regulated voltage, it could cause the unit to go into a shutdown, which is what's happening. It's latching it out. So let's correct those connections first before doing anything else. Even things like this. I know it's not touching, but it's awful close. Wire is kind of long. We'll trim that down a bit. There's someone who thought that the word stop meant squeal tires on pavement. I've resoldered the board, the ones that were obviously bad down here and a few others. Let's see if it works. The unit's still acting up, so I'm just going to do some voltage measurements here. Minus 27 volts, plus 25. These will go to these regulators here. 46, 46, 35, minus 35, minus 46. So that's the positive and negative 35 volt regulator. Work feeds these ones. These ones are fed off that supply that had the connection problem. 25 volts and minus 27. Shut this off and see how fast these voltages drop. Almost instantly. Checking some of these caps, I see that the circuit glue has gotten on some of these transistors down here. I'm going to pick this out. There's this circuit glue that they glue these things down. This cap tests okay, but there's some circuit glue around here that's on some of these components. I'm just going to clear that out, just to rule out that we're getting a short from conductive circuit glue because of how this thing's behaving. I'm going to pull this other cap out as well just to get the circuit glue out from underneath that one. I'll test it while I've got it out. I don't think it's a fault. We can test it for ESR and capacity while I've got it out. I'm sure it's fine. Oops. It'll help if we turn the meter on and zero it out. Yeah. 0.02, 0.002. or 0.02. Yeah, that cap is fine. And if I measure capacity wise on the other meter here, on the Fluke, $2220. So it's a 2200 microfarad, 50 volt. So those caps are fine. But I'm suspecting maybe this circuit glue is not so fine. Because you see there's a bunch of this crap that's covering up other connections here. It's bridging between various conductors, and this circuit glue is known to go leaky and cause problems. So I'm just going to scrape this off. We'll put those caps back in, and I'll scrape it off down here too, because there's more of it down here around the big ones. It actually goes, it's actually corrosive. You can see it's starting to turn green here a bit from the copper. So that's the problem with this stuff. Big time faults when they use this crap around live circuits. Because it doesn't take much to make a transistor go into conduction, right? A little bit of leakage through this circuit glue crap can cause a transistor to either go into or out of conduction, depending on the way the leakage is happening, whether it's biasing it on or biasing it off. And the fact that this resets when you power cycle just says to me that something is not right. But it's not I don't think there's a component that's at fault that's causing this, just from the way it's behaving. I just wanted to look and see if there's any more of that circuit glue and crap that's on the. This is the main controller board here that has the micro and stuff on it, I believe. Looking for it. This is a display driver. This is just the input buttons on the front here. This ties down to this board and this board over here. So there's a board underneath here. This is the battery backup board. Oh, I just took some of the wire ties off here so that I could actually see where the wires go. Because this thing, it's got all these multi-connects, which are a pain in the butt because they don't have plugs on them. They're connectorless. They're either, most of them go to these quick release plugs, or they're soldered right down to the board. And these quick release plugs have been known to cause problems too, where the wires connect. But I'd like to just take a look at this main board here. This is the one that's got the crystal oscillator and everything on it. I'm going to have to remove it from the back. I should be able to flip the board up and look at it. That's where I think where a problem may be, is because of the way it's acting. When you try to turn it on, it turns off and locks up. It's got to be something in here. Because don't think it's the power supply. It's something on the main board, on the control board. And you guys thought that the older stuff was easier to work on. Ha! This stuff is not easy to work on. See what I mean? Ah, man. There you go, boys and girls. That's likely what the problem with this piece of shit is. Circuit glue. And you can see it's turning brown. And that means it's going conductive. That's more than likely what the problem with this piece of crap is. I am going to call this thing a piece of shit because I'm calling a spade a spade. This thing is an absolute nightmare to work on. All these connectors, all these wires, all these multi-connector jumper wires which don't unplug, or they do, they're not keyed. They don't have plugs on them because they're too bloody cheap to put proper plugs on the end of them. It's the reason we called JVC junk very cheap, and it was just crap they turned out like this that nobody wants to work on, including me. We used to turn this crap away left, right, and center if I had any inkling of what this thing was before I said, yeah, I'll take a look at it. I don't know the model numbers, right? I don't know which model numbers are good designs and which ones are crap until I actually get into them. Because JVC had some that weren't nightmares like this, and then they had this nightmare, and there's a bunch of other ones like it. If you get an RX9V, run. Don't walk, run from it, because it's a piece of shit to work on. Pardon my French, but I'm getting frustrated on this thing. Just to take it apart. I spend more time taking this stupid thing apart. See, it's not like you could just remove the whole front panel and take it out. You can't, because there's a metal panel underneath here, under the board. So the board has to be taken out. I mean, it's just, take this apart. If you're paying someone to do this by the hour, this is 2 hours I'm into this thing just to get this thing disassembled. And most likely this is where the problem is going to be, is this crap here. See, when this stuff deteriorates, it becomes conductive. And just the way that this thing is symptom like this, it's just a symptom that something is causing to go into a shutdown. A little bit of excessive leakage detected by the microprocessor, a voltage not quite where it's supposed to be, and then after it sits for, after you power it, cycle it, and it resets, it doesn't see the same fault, and it turns it on. There. Almost might be worth it to try and power this thing up with the boards all out, as long as nothing's shorting out. See if it'll actually turn on and stay on. Okay, the big balancing act here. Nothing's touching. All I've done is scrape the glue. Let's see if it will turn on. Hey, it's on. It's off. Back on. Off. We'll power it down for a few minutes and see if it'll power back up again. Son of a bitch. So I'm just trying to mount the boards back in place so I can power this thing up and see whether I even get any sound out of it now. Because there's a good chance that something else has been foobarred up on this thing. Just the very fact that how much you have to disassemble to get at it, and with these piss poor connectors that they've got on here. I know I'm using a few man words on this thing because it's frustrating. I hate these designs. It's crap like this that when I think back on this crap that I had to deal with, ah man, I'm sure glad I got out of the repair business. It was crap like this that drove myself and so many others away from the business, because it could have been a good unit. It's just that it was, you know, it's like they bodged this thing and threw it together, and it's got to be one of the worst designs with all these stupid multi-flat cables that, you know, I mean, they're so prone to shorting out. I mean, just take a look at this crap. This is what I'm dealing with. This is the biggest problem with these things is, you see, you've got these bare wires where these connectors go together, and it doesn't take much. If they get pushed over too far, you're going to have a short. I mean, it's just a terrible design. Whoever designed this thing should have been taken out back and caned, or worse. And the engineer that signed off on it, well, engineers, it may have started out as a good design, and then someone come along and said, no, we got to make it cheaper. We can't put that in. We can't put these screws, and we're going to use these plastic clips to hold boards in place because screws are too expensive and connectors are too expensive. So we're going to use these zero insertion force ZIF connectors, you know, because you know, they're cheaper. They're cheaper than putting an actual connector on the end of the wire, like Sony would have done. Sony would have put a proper plug on there so you could unplug it and work on it and plug it back in. None of this crap. You piece of... Part of the problem when you use these stupid plastic clips is once you've removed them, they're spread at the front of them. So you got to kind of squeeze them together and try to fit them through the hole in the board and in the chassis. And it's time consuming and frustrating because there's not a heck of a lot of room to work in there. So you're working with tools to try and push the stupid thing in place. You know, this could have been solved if they just put a screw in it to begin with. But an extra metal screw would cost too much. You know, they're trying to get the cost down on these things so they can make the maximum profit and turn out the cheapest crap that they can. So I'm just going to somewhat assemble this thing. I'll put the power supply and stuff back in, and then we'll test it. And I'll let it sit for a while and make sure it's been fully discharged, and see whether it turns on first time. And then we'll start tying some of these ugly flat wires back together. Of course, the problem on this thing, and now we see how much trouble it was that bloody circuit glue. Pretty darn sure that's what the problem was. Now this went in here. I don't know what this did. This was just kind of a bracket that sat in here. I don't even know what it does. It's just like a spacer of some type. What it was in there for, I have no idea, but it sat across. Or was it this other way? It sat across here, inside the... I don't even know what it does. It sits in there like that. I guess what it does, it holds a bracket in place. one sits on top, goes in here somehow. Or was it this way? I hate these. I hate this design. It's just a piece of crap. Let's try it and see what works. The fucking so I get this piece of crap reassembled. Watch what happens if I press on the board. I don't know if you can see it here. Let me lower this down. The display is cutting out on it. If I press down on the board here, oh, come on, stop going down camera. Oh, now it's not going to do it. This part of the display went out on it a minute ago. Now it's working. Try turning it on again. Just turned it off. Okay, now my display's gone out again. I don't know what the hell to say on this thing. See, the graphic equalizer display LCD is not lighting up. The light is lighting up behind it. It's just the LCD display itself is not lighting. And I got no sound. Oh, might help if I'm on the right mode. I'm on AM. Let's try FM. Get no sound. I had sound, and now I don't. All I did was turn it off and turn it back on. So that means I gotta pull this horrible board out again. I'll take one last look at it before I condemn this unit. Could be a cracked connection on one of the big flat pack ICs, because you see it worked when it was apart, but when I put it back together it stopped working. Dropped it. You don't have to take the front off, by the way, to take this out as I'm showing. I just was looking at the front before to see if there was any connections on the front board that were at fault. But the board will come out if you work at it like that. It's still a pain to get at. So the fact that this display went out, there's got to be something in here. I got to look at these flat pack ICs, see if there's any cracked connections on any of them. So for that, I got to get my big magnifying glass out. Okay, that's it. I'm giving up on this unit. When I get a hold of the person that owns it, that has spent over $100 to ship it, against my advice and my dad, and let them know what they want to do. They can either pay to get the thing shipped back to them, or I'll recycle it for them. But this one here is, at this point, I'm going to say not worth fixing. It's got a couple of things wrong with it. I had it playing, as you heard, but this middle display has gone out, which displays the inputs that it's on. It's gone out. I don't know why it's gone out. Again, with all these interconnect wires, you can see the biggest problem with these is some of these wires go to these ZIF plugs, and others are soldered directly down to the board, like these ones here. And you just move them a couple times and they're going to break. It was a terrible design. One of the worst designs that I've ever seen the JVC put out. I think this must have been done by a first-year engineering student or something. But I mean, it's terrible with all these interconnects like this. This is just a terrible way of doing things. These interconnects cause so many problems on these units. And when I worked at the shop, one of these units is one of the few units that we did not want to service. We'd get into a unit like this and it was always a dog's breakfast. So the estimate was always so high to repair something like this that people walked away. So that's what I have to do for this one, is I have to get a hold of the guy that owns it and let him know that I've already spent 2 hours on it now, and not any closer than I was when I started on it, because it's got an intermittent problem. It works, and then I get it together, and it doesn't work, which could be anything, including a hairline fracture on one of the boards. And not necessarily this board, it could be any of the other boards in there that, once you put it together and there's stress put on the cables, they're pushing on the board somewhere, something goes open, and you lose a voltage, and then things stop working. Just a bad design. See, I get a feeling that problem's on this board here, because when I flex the board, the display changes. See? See that? I have a feeling there's a crack on this board somewhere. Just flexing it slightly is making it do weird things. And this display is out completely. The backlights are on, there's just nothing showing through the display. I mean, it's turning on now. But no display, no sound at this time. Okay, I got the display working on it again. Am I going to get any sound? Let's see what mode I'm in here. Am I in? What am I in here? Tape 2. Monitor off. FM. Okay, I got sound. I got my display back. I just, I don't know if it's going to stay back. I just resoldered this IC right here. I went over that IC and I got my display back. I got my sound back. Let's see if it'll turn on and off. It was turning on and off. Let's see if it'll stay off for a while and come back on. I'm just gonna stage a shot of resoldering this IC just for the stage shot. Well, I've solved one problem. It turns on now, but this display is dead again, and I've got no sound. I'm back to square one. Another interesting thing I've noticed is that it's just the radio that's not working. If I switch to the auxiliary input such as CD, it's just the radio that's not working when the display is out. When the display is on, the radio works. Interesting. Now I should note that the radio is tuned, as if I change the frequency you'll see on the display. Right? Go to 87.5, which is where I'm tuned, and it shows FM stereo. So the tuner board's working. It's just the audio is not being switched. I think the switching takes place, it should be on this board here. And this display is out. Okay. I've spent far too much time on this thing trying to chase it after a fault that appears to be voltage related. If I plug the unit in on full mains, I get nothing. If I plug it in through my current limiter, everything appears to work. Let's drop the voltage on the Variac and power it up at various voltages and see when it comes on. Now it's working. I am at like 110 volts now. Let's measure the voltage, the AC voltage. This is the most bizarre problem I've seen in a long time. Looking at my mains voltage here coming in on 120 volts is my mains. I got this running at 110 now. If I turn it off, so you see the display is working, I'll turn the power off, I'll crank it to 120. Doesn't work. Off. Tried at 115. Doesn't work. And it works. Notice the display lit up. Turn it off again, we'll take it up to 115. Doesn't work. The display is out. This is 110. It works. 111. Doesn't. 106. Works great. So I've been spending time chasing after a problem that is voltage related, depending on the incoming voltage. If the voltage is if the voltage is over 110 volts, it's not working. We have a voltage regulation problem on this unit. One of these regulators is applying too much power and causing the microprocessor, one of these micros, to not start properly. Very interesting. Because now we're going to be going back down probably to the regulator board that's underneath here. It'd be nice if I had a schematic for this thing, which I don't, and I've looked. I spent the good portion of an hour yesterday trying to find a manual for this thing, and do you think I could find one? None of my life depended on it. So what I'm doing is I'm just checking some of the voltages as I raise and lower the voltage to the point where it cuts out. So if I raise the voltage up, it'll actually cut out. So I'm just watching to see if the voltages are changing. Minus 15.8 is not changing on that supply. This is the positive side. 15.3. It's not changing the negative supply. It's within a half a volt. Oh. What do we got on this side here? Minus 32. if I increase the voltage a bit, if I switch over to the CD input, it works fine. The display is out though, right? That's the thing, is the graphic equalizer part of the display goes out when the sound cuts out. Run the voltage back down to 110 and it works again. Very, very strange problem. Okay, we're going to take some measurements off the power supply as it goes to the rest of the set, and just we'll crank the voltage when make it cut out. We'll do a comparison. So we got 8.3, 5.9, minus 18, 0, minus 34, and 32. Those are the voltages. We raise the voltage till it's cut out. Now we have 9 volts. Is it 9.1? 9.1. 6.3. I want to see if there's any drastic differences. You see, minus 20. Zero. Minus 37, minus 35, or plus 35, sorry. So this is off of the power supply board itself. So as I was working on this unit, I pulled on this wire, and this wire came out. A little further investigation reveals that this wire goes, this one here, it looks like it got pinched and got cut. So let's just put these ones back together. I wonder, that looks like a ground wire. Could it be that the secondary fault on this unit, I'm still thinking the primary fault was the circuit glue on this thing, and I think maybe a secondary fault got caused when this wire got pinched during reassembly because of this very poor design with all this crap. When you got all these wires out here trying to do any work on it and you're trying to put things back in, it's very easy to get a wire pinched, especially when you've got metal parts. I think that wire got pinched. Let's just stick that wire together. Let's put some heat shrink tubing on around it so that it won't touch anything. And then we'll give it a try. So some heat shrink tubing, and I'm going to use a barbaric way of doing this. I'm going to use my soldering iron just to fuse them together. So I'll just heat the end of the wire enough to melt the insulation. Some solder on the end of it there. There we go. We'll do the same on this one. Just heat it up enough to melt the insulation. And then I should be able to just tack the two pieces together. Okay, wires tacked together. Heat shrink tubing over top of it. We'll blast it with some hot air. We'll just see what our voltage is on the bench. Set for 120 volts and turn it on. See if it turns on. Okay. 121 volts. Damn. I believe this thing's fixed. Holy shit, this thing took a lot of work. Now, I'm going to go back to my original diagnosis. The fault, I'm sure, on this was that circuit glue that was causing problems. Because the way this thing was operating, it was kicking in and out, and it was doing all kinds of weird things. I gotta think that circuit glue was probably because really, well, either that or a solder connection, but was either one of the connections on the board here or the circuit glue that was at fault. I think what happened is when I had the power supply unit out over here, when I put this in, this wire must have got caught and got severed. It wasn't broken off. I didn't actually notice it broken until I took it apart the second time. When I took it apart to do the voltage measurements, because I determined that when the voltage was changed, that's when the sound cut out. When I took this power supply out the second time, that's when I actually noticed this wire, which is hanging there. And did a little bit of research to find out where it came from. So I think it probably got pinched when I put it together the first time and got damaged. Which again this is the problem. Whenever you see one of these receivers, they are absolute joke. How these things got manufactured like this, I don't know. But we call this spaghetti. When you get these spaghetti receivers, they are probably one of the more difficult ones, other than these new, multi-channel AV systems that most people won't even work on because they're so full of DSPs and stuff. But yeah, you get these ones here. Where they work, they're pretty good. But the problem is, because you've got all these multi-connects, and some of them go to plugs, others are soldered down to the board. And every time you move them, you run the risk that one of these wires is going to break. Because even flexing these back and forth in their sockets, they can shear off right here, right? So that's the biggest headache with these receivers, is this problem. And then when you've got all of these wires and you've got all these circuit boards that are jammed together, there's really not a lot of clearance. So it doesn't take much to catch a wire and damage it. And as I say, the wire wasn't actually broken, but it was caught to the point where it had severed the wire itself. And when I took this power supply apart for the second time, that's when I noticed it was, oh, there's a wire sticking out here. I wonder where it goes. Maybe that's my problem. Sure enough, that was the reason why the sound was cutting out when the voltage was at 120 volts, but the sound was there at 110. Weird, huh? Let me get this thing together and keep my fingers crossed that nothing else breaks while I'm putting it together. I'm almost nervous. I was going to get some wire ties around here and tie these down, but I'm almost nervous to do it because I don't want to move them any more than I have to. On another note, I just watched the HBO miniseries Chernobyl, and yeah, wow, that was a really well done program. Again, it's a true event, so it's hard to not have a good program when you're reenacting world events and true events. But that was I think very well done. One more down here just to see. I'm just using whatever color zap ties I could get my hands on. all tied down, ready to go back together. We'll test it again, make sure that I didn't damage anything when I strapped down the cables. It's working. And you know, when you're working on stuff like this, I'm trying to think of catchy titles for what will draw people's attention and hopefully get them to sit down and watch what has become a too long of a video. But on this one, I think I'm going to call it JVC's Problem Child, Taming the RX9V. What do you guys think? Thanks for watching, and we'll catch you in the next one real soon. Be sure to hit that subscribe button. The more subscribers I get, the better I do with YouTube, and it's all about how can we do better on YouTube, right? Thanks for watching. We'll catch you in the next one real soon.